reducing. I'll use my power reducing weapon on you. Okay, so we got these three dudes. Oh, dang. Look, they're kind of similar. Look at that. That's not that bad. Look, sine has the minus because he's getting revenge on cosine, and cosine's finally normal with the plus. And look, it has a 2u stuff in there. It's almost like this 2 power becomes a double angle. And tangent, he gets a mixture of both. Remember, it's sine over cosine? Yeah. Sine over cosine. So it's almost like you just have to memorize one formula for this one. You guys are like, yeah, shut up. Okay. So how do I do this with that? Because this says squared. That does not say squared. It says to the fourth. This is what you do. You take one of the powers out, and then you get busy with it. Okay? This is that formula. So it's 1 minus cosine 2x divided by 2. And then you're going to square that. Can you guys square that? Yeah. Okay, so I'm going to write it all out because I'm teaching it. And I want you guys to see it all. Times 1 minus cosine squared x. Oh, dang. Okay, so we got to do some distribution action. Yeah? Yeah. Okay, so we got, on the bottom we got 4. That one's simple. And then on the top we have 1 times 1, which is 1. And then we have 1 times negative cosine 2x. And then we have negative cosine 2x times 1. So there's 2 negative cosine 2x's. And then the last one, we have cosine x, or cosine 2x times cosine 2x. That gives me positive cosine squared 2x. We could take this fraction out. That's what you get now. This looks a little cleaner right now.
Wait, we're up to the 2x.
What do you mean? The 2x is right here.
No, the 2.
Oh, that should be a 2x too. You're right. So let's use the power reducing formula for this guy. Why? He said why. No. 1 plus cosine 2 times 2x over 2. Oh man, that's hideous. Is that hideous or what? That's illegal. What you did? You didn't call this question Patey? That's. Is that a compliment? Oh. Oh no, you didn't. Oh dang, I'm running out of space. I gotta figure this out. Okay.
Cancel out because you're divided by 2.
No, we can't. No, can't cancel any 2's out. But what I am gonna do is I'm gonna get rid of this fraction here. So there's 3 terms down here. There's this one, there's this one, and there's this one. Okay. Now out of each of those terms, I'm gonna divide each of those terms by 1/2. Okay, you ready? So I'm gonna take a 1/2 out of each of those. So it's gonna be 1/4 times 1/2 on the outside. What is 1 divided by 1/2?
2.
That's 2. What is this 2 in front of the cosine? What is that 2 divided by 1/2?
4.
It is 4. Now when I divide by 1/2, are you guys thinking multiply by the reciprocal?
Yeah.
Okay, good. And then I have plus. And then if I take a 1/2 out of this, I just have the 1 plus cosine 4x. Wow. So now we combine like terms. This 1 can go with this 2, and so now it's a 3. And so now we're back to having 3 terms. We have 1, 2, 3 terms. Now we I'm just gonna rewrite it. Just clean it up. We're done, guys. 1 over 8. The pain is over, guys.
How is that finished?
It's finished.
It doesn't look finished.
Yeah, it looks like a whole nother problem.
You should be used to that because you look at yourself every day.
Oh.
That's it, guys. I know it's hideous. It's not that much fun. It's gnarly.
I kind of feel like we're going backwards.
Yeah.
Yeah.
So here's the thing. What just happened? What did we do?
We did
Okay, but no, stop. I'm going to explain. Do you see any powers here?
No. Oh, we reduced all the power.
Yeah, we got rid of the power. If you guys forgot where we started with that. We started with sine to the fourth. Now, sine to the fourth can be written like this.
Oh my gosh.
Alright, cool.
Okay, and that just says, that's what it says. It says, write this as a sum of first powers of cosines and multiple angles. So here's cosines, and there's multiple angles inside. So this is almost like a trig identity. You know how you have to do all that work to try to simplify it or make it look like the other side? It's almost like that, but we're using formulas instead. Well, I guess it's a weird thing to say, but yeah, they're all formulas. But